Hello and welcome back. We're going to continue our discussion of separation of variables. And for the most part, this is really easy to do. Let's just take a look at examples number 1 and 2 here, where we want to separate the variables. Now, what we mean by that is we want to separate each variable. For example, here I have an n, and I'm also looking at the z's. So I want the n's to one side and the z's to the other. And I can do this pretty easily. Typically, though, we want to leave the dn, the top one, the variable on the top, on the left. And the one with the z, or the bottom one, we're going to move that to the right. So I can do this just by cross multiplying. I'm going to bring this 1 minus n over, and that's going to give me 1 over 1 minus n dn. And that's going to equal, and I'm going to multiply both sides by dz, and that's going to give me z squared dz. We're not going to solve this one just yet, but we will in a few days. So right now, just leave that one alone. That's going to be ugly when we solve it. All right, for number 2, same thing. Whoops, there's an error there. That should be a t. Please forgive me. So I'm going to bring the 3y over, and I'm going to bring this dt over to the other side by cross multiplying. So this would give me 1 over y. Now notice, I'm leaving the 3, so I probably should erase this. I am going to only bring over the y. That makes it less complicated for us later. So that's going to become dy, and this becomes 3 over t squared dt. Notice we have the y's to one side and the t's on the other. We don't want to mix our y's and t's. We want to leave it where we have our variables, what is called separated. Now on the AP, you are going to get just 1 point for doing that. But we're going to talk about this. This is worth a lot of points. So let's talk about how we solve these then. To solve a differential, we have this little step here. 1, you want to separate the variables, and then we're going to integrate. Now, separating the variables on the AP, this will typically be worth 1 point. The integration could be worth 1 or 2 points, but then we got to solve for C. That's 1 point. And then solving it with any restrictions and the function, you get typically 1 point for that as well. So let's have some fun here. So for the first one, we want to solve this. So the first thing we're going to do is I want to separate my variables. Notice I got my y's and I got my x's. So I'm going to bring my x's to, I'm going to bring over my y's, my dx over, and I'm going to bring my y over by cross multiplying. That's going to give me y dy equals 2x dx. Now, we're given this initial condition. This is going to come later. We saw this earlier this year when we had to solve for C1. We'll talk about that later. So my first step now was to separate, and now I have to integrate. Now, I already got 1 point. When I integrate y dy, that's easy, y squared over 2. Again, from above, we're not going to worry about the plus c here. We're going to add it to the right side instead. Integrating 2x, you should be good at this. That's just x squared plus your constant. Now, let's talk about points. You get 1 point here, 1 point for your antiderivative, 1 point for your plus c. Take a look here. If you do not have this, you get no more points. If no more constant, no more points. So at this point, I am going to solve for C2, C1. Solve for C1. To do that, I'm going to use my initial condition. Y of 1 equals negative 3, and I'm just going to plug it in. My x is 1, my y value is negative 3. If we plug negative 3 in, we get 9 over 2 equals 1 squared plus C1. So C1 is equal to, well, what's 9 halves minus 1? So it's what, 4 and a half minus 1? So 3 and a half or 7 halves right there. Pretty easy to do. Write out your equation, my function. So I'm going to write this out. Y squared over 2 equals x squared plus 7 halves. Multiply through by 2. Y squared equals 2x squared plus 7. Take the square root. We get y is equal to, now remember, we get plus or minus. We're taking a square root. 2x squared plus 7. But be careful of your signs. Notice the initial condition says that we have a point y of 1 equals -3. Notice this is a negative. So of the two I'm going to pick, I picked the negative y. So therefore my function is going to be y equals the negative square root of 2x squared plus 7. Check any domain restrictions. That's easy. Just set the inside greater than 0 or equal to 0. We get x squared greater than or equal to negative 7/2, and we don't have any because x squared is always going to be greater than -1/2 because x squared is always positive, so therefore there are none in terms of domain restrictions. That our answer here will never be negative on the inside there. The hardest part you're going to find, making sure you remember to pick which sign. So let's try number 2. Same exact type of problem here. Ready? When I separate out, we should get y dy equals x dx. When we integrate both sides, y squared over 2 equals x squared over 2 plus c1. And I'm going to solve for c1 now. My initial condition is y naught equals -2. If we plug it in, there's my y value, there's my x. So we're going to get 4/2 equals 0 plus c1. So c1 is just 2. Writing it out, y squared over 2 equals x squared over 2 plus 2. Multiply everything by 2, right? We get y squared equals x squared plus 4. Take the square root. Be careful. You get 2 answers. But remember, my initial condition says it's negative. So this is a negative y. So I'm going to pick the negative down here, and we get negative square root x squared plus 4. There we go. All right, so let's go and try number 3 here real quick. Look how fun these are. So when I bring over if I look at number 3 here, I'm only going to bring over the y. Don't bring over the 2. Well, I guess we can in this case. Bring over the 2y. Why not? That's going to give me 2y dy equals 3x squared plus 1 dx. Now notice, make sure y is on one side, x is on the other. Just like any relationship, put your y's on one side and your x's to the other side. Now we integrate. Of course, this is just the left side just going to become y squared. The right side is going to give us x cubed plus x plus c1. Don't forget the constant this time. It's very important. Now that I got that, now I can solve for c1. My initial condition, y of 1 equals 4. Notice this time it's positive, so that's cool. And I just plug in. There's my y value, there's my x. So we would get 16 equals 1. 1 cubed is 1 plus 1 plus c1. c1 is just 14. So our equation, y squared equals x cubed plus x plus 14. And then I take the square root. But be careful, how many answers do we get? 2. But we're only going to pick the positive this time because notice our initial condition, y was positive. Remember, we get 2 answers when we take a square root. But my condition says I only want my y's are positive because that's what it says. Y is positive or y is negative. My initial condition says y has to be positive. So I pick my positive y's. Square root of x cubed plus x plus 14. Whoops, that's an ugly looking 14 there. Let me go ahead and fix that real fast. Plus 14. Okay, well, I hope you enjoyed this video. Go back and take a look at video number 3. We'll take a look at some more examples. I'll see you then.